Yes friends, so we are continuing with question number 2 now, but before that I just concluded the four ways of or the four approaches to the probability, definition of probability, how to define probability with the help of these four approaches. The last approach, which was very important, okay, was established in 1933, okay, by A.N. Kolmogorov, right, Kolmogorov, and a Russian mathematician, and that was based on axiomatic. That was axiomatic approach. Axiomatic. The fourth one was axiomatic approach to probability. What is axiomatic approach? I just discussed about that. This is based on three approaches, three axioms. What are the three axioms in the fourth one? The fourth axiomatic approach includes three basic axioms or postulates. We can say theorems or postulates or axioms. What are those three axioms, three basic considerations or basic conditions? First condition is this, that the probability of an event based on either the event is certain or uncertain. If event is uncertain or is not going to happen, is impossible event, then its probability will be 0, right? So the probability of an event ranges from 0 to 1. This is the first axiom. First axiom is that the probability of an event ranges from 0 to 1. If the event is uncertain or is not going to happen or cannot happen, then its probability is 0. If the probability is certain or it will happen or it happens with 100% certainty, then its probability is 1. So, a probability of an event ranges from 0 to 1. This is the first postulate. Then the second postulate I talked about, that the probability of the entire sample space, the finite sample space, is 1. So probability of S is equal to 1. So the second axiom, this is the second axiom we consider, or the definition of this axiomatic approach considers. Okay, the second axiom is the probability of the finite sample space is 1 always. Then the third axiom is the third one. In the third one, we take that when the two events, suppose A and B, the two events are mutually exclusive, okay, or two sample points are, or two events are mutually exclusive. Suppose A and B are mutually exclusive, then the probability of occurrence of these two events, A and B, like probability of A union B, is given by probability of A plus probability of B. Okay, the probability of the two events which are mutually exclusive is probability of A union B is equal to probability of A plus probability of B. So this is the third axiom. These three axioms are basic axioms on the basis of which the fourth approach is considered very important one, because this defines the probability in detail. Okay. Before that, precise definition was that what is the probability of an event. Probability of an event is given as number of favorable cases divided by total number of equal likely cases. That is the basic definition of probability. Okay, and that we know about. The probability of basic definition of probability is that number of favorable cases divided by total number of equal likely cases. This result or this ratio comes out to be or gives us the probability. That what is our chances, what is the favorable cases, okay, out of the total number of cases in favor of our event which is going to happen, okay, or the act or the experiment which is going to happen, which is going to result into an outcome. Okay, that outcome is positive in favor of the event which we are going to happen, or the occurrence of event is going to happen. Then in occurrence of that event, what are the favorable cases? That divided by total number of equal likely cases. This is the basic definition of probability, and on the basis of this, these are the four approaches we have discussed up to now. Now that we take the second very important question here. Why I have taken the basic three important questions here? Because they are defining the whole basics of probability. Why basics of probability are must? Because only then we can understand, because the permutation, combination formulae are mostly used in case of probability. So before that I have already discussed that probability, what are the combination and permutations, questions based on permutation and combinations. I have discussed them in detail, and after that the usage or the application of combination formula is very much required in case of calculating the probability. Okay, so solving probability questions based on probability requires combination formula. Importance of combination or permutation I have already discussed about. I have discussed the questions based or what are the formulae used. Okay, so selection process if is done, then combination formula is used. So in this case, case of probability calculations, we have to use combination formula because that is used for selection. Now come to the point. Second question says the random, this define the following terms. These terms, if are obvious or clear, then we can understand that what is the probability. Now let me take these terms. Second question gives us define the following. The second question says define the following terms. Define the following terms. Let me write the whole question. Define the following terms. Now let me take the terms one by one. The first term is the random experiment. What is a random experiment? Let me talk about. It says random experiment. So an experiment or you may say an act, a trial or a trial which is repeated. Random means which is repeated. Okay, but the result of which is not certain, which may not repeated. An experiment, we can say an experiment or a trial. This is random experiment. So the following terms, random experiment are not written. Random experiment, sorry. This is random experiment. What is random experiment means? I'm sorry, this whole word was random experiment. Sorry for this. Random experiment is an experiment or a trial or an act which we are going to do. Okay, for example, tossing of a coin. If tossing of a coin is repeated, but in case of repetition, okay, based on certain conditions, and the repetition is not giving us the same result again and again. No, the result may be different. Okay. This is the basic condition, that under certain conditions, when the trial is repeated or trial is repeatable, or that experiment, that act or that trial or event is known as repeated event, but the results are different. Results are not same, repeated again and again. No, we cannot say that. That is, so experiment means which can be repeated. You know about experiments. Experiment which is repeated, you know, is random. Random experiment is an experiment or a trial which is repeated, but its results or outcomes are not same again and again, or they are not repeated again. They are not same again, or not certain. Not certain is not repeated. Not certain or repeated. You can say repeated. Result is not repeated, but can be tried under certain conditions. So given on conditions. For example, if I take, let me take a coin is tossed. For instance, a coin is tossed. Okay, be ones, let me take the ones. Then either head will come up, head will appear or will show up, will appear, or tail tail will appear. But we cannot see if it is unbiased. If coin is unbiased, fair, this is must that it must be fair, equally likely. Only then we can say that experiment is repeated, but is not, the result is not repeated. The result cannot be same again and again. It may be either of the result. In this case, only two events are there, or two you may say sample points are there. Two events or either head or tail will appear. So, but it will appear head or tail, we cannot say certainly. If coin is unbiased or is fair, we can say the fair coin is there. Then we cannot say this. So, will appear. So, if the coin is fair or unbiased, fair or unbiased, then we can say that this is not going to be repeat. The result is not going to repeat. It may either tail will appear or head will appear. We cannot say with certainty, but it can be repeated. Suppose 2 times if I repeat it, then first time it has appeared, suppose tail. Second time it may come head or tail. We cannot say anything. That is how random is. Random is repeated experiment. So a random experiment, a trial or an experiment or a trial which is repeated, but its result or outcomes are not same again, or not certain or repeated. We can say certain is not repeated. Certain are there, result will be there, but the result is not repeated. So that is known as random experiment. Okay, so this is the instance we have talked about. Now second point is what is the random experiment we have talked about. Now second, let me take the second term. Second term of this, let me write this basic following terms. I'll just write the terms only. Second term is, what is second term? Second term is sample space. What is sample space? Sample space. So we can say a collection of all the events or sample points or outcomes of an event, of an experiment, of an event or trial, or a random experiment, or a random experiment, of a random experiment. Okay, so all the possibilities, or the collection of all the events or sample points or outcomes of an event or a trial, or a random experiment or a trial. Okay, a random experiment is known as sample space. Is known as sample space. This is sample space. Okay. For example, if let me take a die is thrown twice. Suppose a die is thrown twice. A dice is thrown twice, or a die is thrown twice. I say die because die is singular one. And dice is plural. So a die is thrown twice, for example. Okay, if let me take die is thrown once only. Is thrown once. Then its sample space. Then its sample space we write SP, sample space. SS, sample space. S, capital S, is denoted in curly brackets. The event 1 can appear, the number 2 can, 3 can appear, 4 can appear, 5 can appear, 6 can appear. Now if it is done twice, then because these are total 6 events or 6 sample points, so 6 raised to 2 twice, 36 events will be there. Okay, so total 36 sample point, and the point, I mean the events which are written here, all the possibilities, they are known as sample points. So collection of all the sample points is known as sample space. All the possibilities are written in the bracket. This is mostly curly bracket is used in case of representing a sample space. So sample space is the collection of all the possibilities, all the events, all the trials, all the outcomes, you may say, all the sample points, all the events, okay, which are expected in case of a random experiment, or okay, of a trial. This is a sample space. Any sample space. Suppose our coin is tossed twice or thrice. Suppose thrice, then 8. 2 raised to power 3 means 8 outcomes are there. 8 sample points are there. That they can be H 3 times and till last 3 times. And in between 2 times had, then 1 time had, we can repeat that. Okay. 2 times had means H T T H, the 3 possibility, and similarly 3 H T we have taken to T only repeated. Then 1 had 1 H T T or T H T T T H. The 3 possibility, 3 plus 3, double head, single head, 3 possibility 6, and triple head means H and T T T. There are the total 8 possibilities in case of when coin is tossed 3 times to 2 raised power 3 is the total number of sample points. Okay, sample space in that case will be that. So sample space is the collection of all the possibilities, all the outcomes, you can say, the sample space. Now let us talk about third. What is the third point here? Third term. The third term, we have to know about all these things. What are these sample terms? I mean, sample point, sample space, we have to random experiment, sample space, sample point or event. Sample event. Now sample point here. Sample point or event. Sample point or event. Okay. So sample points, we can say sample points or events. So all the outcomes, okay, or results in a sample space, of a random experiment, are known as sample points. Okay, so they are known as sample points. Okay, so these are sample points here. For example, or for instance, if a coin is tossed, let me take 2 times, or 2 coins are tossed at a time, or 1 coin is tossed twice. Same thing. Okay, 2 coins are tossed at a time, or 1 coin is tossed twice. If a coin is tossed twice, 2 times, okay, or twice, we could say tossed twice or 2 times. Then sample space S is equal to H T T H and T T. These are the 4 possibilities. Why? Because 2 in one trial, tossing, there are 2 possibilities H or T. 2 raised to power 2, that means 4. There are 4 possibilities in case if it is repeat, if it is done twice, then total number of sample points will be 4. If it is repeated thrice, then 2 raised to power 3, total sample points will be 8. If it is repeated 4 times, then 2 raised to power 4, 16. 16 will be the sample points. So sample points are these outcomes, these events, these results, we can say. The outcomes are known as sample points. Okay, or the points, a sample space. Okay, all the outcomes in a sample space are known as sample points. So these are the sample points here. So HH is sample point, HT is sample point, TH is sample point, TT is sample point in this case. Similarly, others can be described. Okay, so this is how sample points are there. Sample points, sample space, we have discussed about random experiment, we have talked about. Under certain conditions, random experiment is done. We cannot say that this will be repeated. Okay, whatever conditions given to us, it must be a fair point here. Fair, anything, whatever trial is done, that must be fair. A coin must be fair, a die must be fair, or dice must be fair. Okay, and then the cards must be, playing cards must be fair. It should not be any wrongdoing. Playing cards are not similar, they are different. In that way, we can say they have the different numbers or different, the names given to the cards, like queen, okay, and then king, queen, and what are the other, slaves, etc. Okay, so the names are given to them, they must be different. Two cards are not similar. Similarly, so they are unbiased, fair or unbiased. It must be unbiased, right? Now come to the point. The third one, or here we are taking A, B, C. I'm sorry, this is not C we have taken. I'm sorry, this was C here. Now D. So first A, B, and C we have done. Sample point. Now sample even. Now equally likely evens. What are the equally likely evens? Let me talk about D. D point here is equally likely evens. Equally likely evens. Equally likely evens. Okay. For example, the events which have the events or outcomes are equal chances of occurrence. I'll just talk about this. What is equal chances of occurrence? Or no bias or disparity is done, or okay, the experiment must be fair. Okay. The random experiment must be fair, or the random experiment if it's fair, then it is equally likely. The random experiment is fair, or the coin tossed is fair, or coin, dice, or cards are fair, then they have equal chances of occurrence. Chances of occurrence. For example, if a coin is tossed, okay, or we may say that if a die is thrown, suppose if a die is thrown, okay, a throwing of a dice, or a die or dice, they say dice. A dice is thrown, dice is plural verb. A die is thrown or dice is thrown, no problem. Okay, a die is thrown once, then sample space S is 1, 2, 3, 4, 5, and 6. All these outcomes have the same probability, 1.6, 1.6. 1 is coming one time only. Total number of possibilities are 6, so 1.6. So number of favorable cases, suppose 1 is to appear, then 1 upon 6. So each activity has a similar type of occurrences, same probability, same possibility. 1 can appear, probability is 1.6. 2 can appear, 1.6 probability, 3, 1.6. So this is a fair coin, and it is equally likely events. Equally likely events are When if fair coin is there, fair thing is happening, experiment is fair, then there are equal chances of occurrence of every outcome, every sample point is not repeated, but it is happening with equal chances, equal possibilities, equal probabilities. They are known as equal likely events. Equal likely events are these. We can say when they have the equal chances of occurrence, then we say equally likely events. This is the point we have discussed about. Let me talk about E point. What is the E point here? Now the E point. In question number 2, what is the E point of it? E point says events. What are the events? Events we have discussed about as sample points. Events we have taken now. So events, the outcomes of a trial is known as an event. Is known as an event. Okay. So the outcomes of a trial are known as events. Let me take what the outcomes I have taken here. Of a trial are known as events. Or we can say sample points. In this case, sample point and events are same. Sample points. All these events, we can say the events or sample points are the outcomes, which are the points collected in the sample space. Sample space contains all the events or sample points, we can say. So events are the trials, the outcomes of an event, of an experiment. The outcomes of a trial are known as events or sample points. Okay. For example, or for instance, in tossing of a coin, okay, the two events are head and tail. Okay, so sample space will have either head or tail will appear. This is once only. In tossing of a coin, the two events or H and T, two events H and T are expressed as sample points, are expressed as sample space equal to H and T. So H and T are the events, we can say events, okay, or sample points. So events are the outcomes of a trial. Trial is just we are tossing a coin. This is trial. What is the outcome? What event? Occurrence of that event, that outcome. Occurrence of that trial is known as event, which has appeared as an outcome. The outcome is an event. The event has occurred, or that outcome has come up. Either head will appear or tail will appear in case of tossing of coin. Anything which is happening, the resultant of that, the results of that, outcomes of that are known as events. Simple. So this is what events are there. Now let us take simple event. What is a simple event? Now let me talk about F here. Now definition of events we have talked about. What is F here? Simple event. Simple event. Simple events. If an outcome is single, if an outcome is single, then it's known as, then it is simple event. Then it is known as, simple event. Simple event. Okay, and probability of that simple event, let me take A, is given as again the number of favorable cases in the numerator